When data has been already grouped for us, sometimes it can be a little bit more challenging to find our measures of center, or sometimes they're called our measures of central tendency. So let's take a look at one more example of when data has been grouped together, how we can find the mean, the median, and the mode. So here I have a data set for scores on a 24-point biology exam. So this has already been organized for us into a frequency distribution, so we are no longer seeing the raw scores. Except because the data value that we're tracking, or that score, is a discrete value, it's countable, we don't have an interval of values in each class. So what this data table is telling me is that the score of 1 occurred with a frequency of 1. So maybe I'm going to write some of the data set up here. So the score of 1 occurred once. The score of 6 occurred once. The score of 7 occurred twice. The score of 8 occurred 6 times. So 1, 2, 3, 4, 5, 6 eighths. The score of 9 occurred 10 times. All right, and I'm getting tired of writing out this data set, but hopefully this is where you can kind of see what the actual data is that we are tracking, is the scores on the biology exam. The frequencies just tell us how many times that particular value occurred. Now, if you went through here and you added up all of the frequencies, these would sum to 75. So that means I have 75 data values in my data set. So for those 75 values, let's find their mean, median, and mode. Let's start with the mode first. It's the easiest one to find. So the mode is just the most frequent value that occurred in the data set, or the one that occurred with the highest frequency. So in order to find my mode, what I'm going to do is I'm going to start looking through all of these frequency numbers down here, and I'm going to find the one that occurred the highest. So the highest frequency I'm ever seeing is the 16. So the 16 occurred for the data value of 10. So the mode for this data set is 10. That score occurred the most often in my data set. It occurred 16 times. Be careful when you report the mode. I don't want to know what the frequency is. I want to know what the data value is that is the mode. So for this data set, my mode is 10. Okay, so now let's go ahead and find the mean. So to remember to compute the mean, what we're going to do is you're going to find the sum of all the data values in the data set, and then you're going to divide it by the number of values that occur in the set. So we'll maybe call it the total number of values. All right, so the total number of values in my data set, we had said you can find that by adding up all the frequencies. So there are 75 values in my data set, so that is going to be my denominator. Now what do I get if I sum the data set? Now, to sum this, you could look back up here where I started writing out the kind of the raw data, and you could put in your calculator 1 plus 6 plus 7 plus 7 plus 8 plus 8 plus 8. I guess if you wanted to, you could do that. You'd be keying in 75 data values with pluses in between them. That would get a little tedious and time-consuming. Remember, multiplication is a way to represent repeated addition of the same number. So I can pair the score with its associated frequencies to find what I would get to contribute to my overall sum just for that data value. So what I mean by that is the score of 1 occurred once. So I'm just going to go ahead and write 1 times 1 to see the score of 1 occurred 1 time. So it's going to contribute 1 to my overall sum. I'm going to add to that the score of 6 occurred once. So I can write 6 times 1 and I get an overall contribution of 6 more to my overall sum. The score of 7 occurred twice. So I could either do 7 plus 7 and get 14, or I could look at the values in my table and do 7 times 2. And that's another way to get the 14. The score of 8 occurred 6 times. If you wanted to, you could do 8 plus 8 plus 8 plus 8 plus 8 plus 8, or we could do 8 times 6. So the scores of 8 are going to contribute 48 to my overall sum. That's what we get when we do 8 times 6. So I'm going to continue in this manner with multiplying each score by its associated frequency all the way down. Now there's still a little bit to enter in our calculator, and there's still room for error when you're keying all that stuff in, but it's less button pushes than trying to sit here and key in all of these values. Okay, so I'm going to record ... meaning I'm going to continue in this manner until I get down to the last one, which is 24 times 1. Now this is how I would record my work so I could remind myself of what I was doing. I was taking each score and multiplying it by its associated frequency, and I'm going to repeat that for all of the data values in my frequency distribution. But when I actually go to key this in my calculator, just to share with you, a little bit of a shortcut, I don't actually key in all this multiplication. I do the ones in my head that I can. Meaning when I go to key in my calculator, all right, so 1 times 1 is 1, so I'm just going to hit 1 plus. On the next value, 6 times 1 is 6, so I'm just going to hit plus my 6 and then hit another plus. 7 times 2 is 14, so I'm just going to hit plus 14. So anytime I get to a multiplication I can do, I'm just going to key in what I get when I multiply. So 8 times 6 is 48, 9 times 10 is 90, 10 times 16 is 160. So I'm just going to keep adding those values, doing the multiplication in my head, and as soon as I get to one that I don't know, so 11 times 13, I might not know that one off the top of my head, so at that point in time, I will key in my calculator 11 times 13 plus, and then I'll just keep going in the same fashion. Your calculator will follow order of operations. It will do the multiplications before it does the addition and add everything up. Okay, so it's maybe just a different way to key all that in if you weren't certain how to maybe make that a little bit shorter. In any case, I encourage you to try this on your own, key all that in, make sure you're careful with your button presses. You should be getting that the overall sum of all the data values is 814. So then I have 814 divided by 75. And if you do that division, you should be getting 10.85333 ... Now, typically you're going to be told what to round to, but just so you know, if you are not told, rule of convention is to round to one more decimal point than the data set is. So if you're told what to round to, definitely follow those rounding rules. But if you're not, round to one more decimal point than the original data. All right, so since my original data are all whole numbers, I'm going to round it to the 10th spot. Since that number is 5 or bigger, I am going to round this number up. So this is approximately equal to 10.9 for the mean for this data set. All right, so the last thing we're going to look at is we're going to find the median. So the median is the value that falls smack dab in the middle of your data set, assuming that your data set is ordered. Now I want you to notice that these scores are ordered. They are ordered from least to greatest, so I don't need to order my data set. It is already ordered for me, so yay. Ordered. There it is. All right, so already ordered. So let's find out what then value would be halfway in my data set. So if I have 75 values, now notice that that is an odd number. So your median will be the value that is smack dab in the center. So 75 divided by 2 is 37.5. So that means then that the median is the value that is in the 38th spot. Okay, if you want to try to visualize it, I'm going to have 37 data values over here, 37 data values over here. Right, so that'll account for 74 data values. Then this number that sits right here, smack dab in the center, where I have 37 values to the left of it and 37 values to the right of it, that number in the middle is going to be my median. So notice that that is going to be the value that sits in that 38th spot. So we need to find out who sits there. All right. So again, they've already organized this data for me, but sometimes as part of the organization, it gets a little confusing about how do I use the frequencies in order to find the score that I want. And there's where we're going to come back up to kind of the raw data I've written up here to motivate us. So notice that 1 occurred in the first spot and 6 occurred in the second spot. Okay, it was 1 more than the first spot. So if I have the first spot plus the second spot, 1 plus 1, I've now accounted for 2 data values. And I've accounted for values that would be through the second position. 7s eat up 2 more spots. So the 7s will go through the 4th spot. So if I was already in the second spot, I'm going to eat up 2 more spots. So now I'm in the 4th spot. 8s are going to eat up 6 more spots. Now I was already through the 4th spot. So now I'm going to eat up the 5th, 6th, 7th, 8th, 9th, and 10th spot. So 8s will eat up through the 10th position. How could I have seen that? Well, if I was already through the 4th spot and I'm going to use up 6 more spots, 4 plus 6 is 10. So now I'm through the 10th spot. 9s are going to use up 10 more spots. So hopefully we don't have to write out the list of 9s in order for us to see that the 9s are going to use up through the 20th spot. So the last 9 will be in the 20th position. Now remember, the goal right now is we're trying to find out who's in the 38th spot. Now I've only eaten up through 20 spots, so we got to keep going. So if I've already eaten up through 20 spots, 10s are going to eat up 16 more spots, so that'll eat up through the 36th spot. Now I'm really close, but let's make sure. The 11s are going to eat up 13 more spots. So if I was already in the 36th spot and I eat up 13 more spots, that's going to be 36 plus 13, or I'm going to be through the 49th position. All right, cool. So I remember I was trying to find the number that's in the 38th spot. So 10 wasn't enough because that only eats up through the 36th position. The 11s will stretch from the 37th position through the 49th position. So the value that is sitting in my 38th spot must be an 11. Okay, so the median of my data set is 11.